let's think about some of the big ideas in computer engineering. The digital abstraction allows us to use electronic circuits in order to represent logical values and functions. On the left-hand side, we have a symbol for an inverter, which is a logical negation. On the right-hand side, we see a set of waveforms. The input waveform goes from a low voltage to a high voltage and then back to a low voltage. Those represent zeros, ones, and then zeros. The output responds starting at a high voltage, which represents a logic 1, then moving to a low voltage, which represents a logic 0, and then back to a high voltage for logic 1. The digital abstraction is key to harnessing the power of electronic circuits in order to perform the mathematical operations that define computing. Sequential logic is another key abstraction. Rather than just let these circuits run, we use a clock to manage how we go through a set of values. The box is a register that holds a value. When it reads a new value is managed by the clock signal at the bottom. It will then provide that stored value to the output, which can be used by logic. When the clock commands, a new value can be read into the register. Hierarchical design refers to the way we use abstraction and refinement to create and verify computer systems. In this case, we have a data path and a controller. The data path, in turn, includes several components, including a register file, an ALU, and another register. The controller, similarly, has its own internal components. We use divide and conquer in order to take complex systems and break them down into smaller pieces that we can deal with more easily. Computers rely on memory for their operation. We store both programs and data in memory. The CPU fetches instructions, fetches data, and executes operations. We use the term storage to talk about devices that provide long-term retention. Many, although not all, memory devices require power to retain their values. A storage module will retain the values it's storing even when power is removed. Both memory and storage provide huge capacities with very high reliability. Generally speaking, a given computer system has even more storage than it does memory. Directly writing instructions for CPUs would be both time-consuming and error-prone. We use programming languages to provide a level of abstraction above the computer. Compilers translate those programs into instructions and data for the CPU to interpret. Operating systems manage the resources of the computer. That includes the execution of the programs, which program is running at any given time. Manages storage in the form of files and other types of storage. Manages the networking connections to other computers, and it provides utilities for user interface. Computer networks allow computers to talk to each other, whether that be over wired connections or wireless. Abstractions in software allow different types of computers and different types of networks to talk to each other, that is, to interoperate. Thanks for watching.